Good evening, everyone. I think I made a mistake by not switching on the video. Let me check it out. Yeah, I think now it's on. Okay. Welcome to the misconceptions in physics. Just a moment. It does seem to be very dark. Right. Okay. Right. Okay. So this is the 23rd video on rotation. There are several videos which have been done so far. So to understand about the several concepts which are used in rotation, how to use it, where to use it, when to use it, and so on. Because rotation is definitely a concept-oriented chapter, which forms a very, very high weightage in case of the other competitive examinations like JEE mains or advanced. So this I thought, okay, let me just explore most of the concepts in however way it has been asked. You should be able to string them together and put it across. So an attempt has been made by me to solve some problems in HC Verma, which I observe when I teach the students that they do make mistakes in such problems. And thus I started working on this. Okay, without wasting our time, let me just share my screen to see what is there for us today in the cart. Right. So this is the 23rd problem. Now this problem is an extension of what we have already observed in the previous example. The previous example, in yesterday's example, if you had noticed it, okay, so what we did was, this was the one which I have did over here. So as you see, you had a uniform rod of length L lies on a smooth horizontal surface, and when a particle hits it, this particle comes to stop. There is an elastic collision, and this rod starts to rotate. And as a result of it, the question was, so when the rod becomes perpendicular to its original configuration, then what is the distance traveled by the center of mass of the rod? We did this example. Please go through this, okay, so that you can really get to know how much physics has been involved in understanding this. In the previous video, it is MROT22, the 22nd video. Now in this video, I'm just continuing with the same problem. It's another problem given the HC Verma, but I have modified it a little bit. Okay, and then uniform rod of length L lies on a smooth horizontal surface. The same problem once again. And then, so let us say its length is L, its mass is M, smooth surface, its friction is mu equal to 0. Okay. A particle moving on the table strikes the rod perpendicularly and sticks to it with a speed v. So a particle that moves with it, it goes here, it sticks, and it was before sticking, its velocity was v. Right. The rod has a mass m. Find the velocity of the particle and the rod with respect to the center of mass before collision. Find the velocity of the rod. Find the velocity of the particle and the rod with respect to center of mass. Now, what the student has considered is that when the particle goes and hits over here, what is the velocity of the rod before collision? Remember, before collision. Before collision, what is the velocity of the particle? Particle's velocity was v. What is the particle? What is the rod's velocity? Rod's velocity is 0, right? So velocity of the particle is v and the rod is at rest. So velocity is 0. And as a result of it, he just gave the answer in a very, very easy way. There's a problem from H.C. Verma. I do not know how much difficulty he had thought of, okay, how much great he was in thinking about this problem and putting it across. But the student, most of them, 99% of them had given this. And when I discussed this in the class, many of them responded, sir, what is this? This is such an easy problem you have given to me, and that for 4 marks. Is it required? Okay, now let me solve this. So this solution is completely wrong. It's a misconception. The reason is because, read the question once again, find the velocity of the particle, right, rod, with respect to the center of mass, right? Now, with respect to what are this velocity v and rod? Velocity of rod is at rest. Velocity of rod is at rest with respect to the ground. If I am an observer sitting on the table and I observe what is the velocity of the rod, it is definitely 0. What is the velocity of the particle? I turn back and say, oh, velocity of the particle, velocity is moving slowly over here. It is 0. I agree. As it's v. But here in this case, it is not that. So here what's happening? Here you can see that it is with respect to the center of mass. Okay, then where is the center of mass? Is the center of mass the center of the rod? No. Center of mass is not the center of rod. Why it is not so? The reason is because this is my rod. Okay, let me take up a new slide and then try doing this one, show you. Let us look at the correct solution. Now you have a rod and then this is the particle. This is the particle of mass m, and this is moving at the velocity v. This mass is m. Just a minute, something wrong here. Okay. I think it's working now. Well, right. Now, the question was that where is the center of mass? The center of mass is not at the center here. Okay. Center of mass is not at the center. See, how do you find the center of mass? Now, first find out what is the velocity here. You know, center of mass formula is given by VCM, okay, is equal to M1 V1 plus M2 V2 divided by M1 plus M2. This is the center of mass, right? So as a result of it, now when this particle is moving and this particle is not moving, when this capital M is equal to 0, let us take capital M is equal to M1. Okay. So therefore, I'll write capital M into 0 plus M2. M2 is nothing but M. M into V2, it is nothing but V, divided by M1 plus M2, which should now be equal to MV divided by M1 plus M2. Okay. So this VCM is equal to so much. Definitely. So center of mass should be, the position of center of mass should be somewhere between the line joining these two, which should keep on changing as the particle keeps on moving like this. Okay. So the center of mass is over here. So it should also be moving like this, right? So with respect to this, now he is asking you to find out with respect to this being the origin, what is the velocity? What is the velocity of the rod, right? Before collision. So as a result of this, find the velocity of the particle. Find the velocity of the particle before collision with respect to this velocity. Now, this center of mass is also moving with this velocity, which is VCM. The particle is also moving with the velocity V. Now, how do you find what is the velocity of the particle with respect to this? This problem is very similar to that of asking the question. There are two cars. Okay, one car is moving at the velocity V. The other car is moving at the velocity V1 over here. Now, this is the origin. Okay, with respect to this, what is its velocity? What will you say? Obviously, the answer is, it is, if this is V and this is V1, then you can say it should be V minus V1, right? So therefore, here also you can say this should be equal to V minus VCM. Now, what is VCM? We already know this, which should now be equal to, this is what? This is particle's velocity with respect to the moving frame. What I'll do is, with respect to, okay, let me write this V dash. V dash is equal to V minus VCM, which should be MV divided by M plus capital M. Okay. So when I do this, what do I get here? MV plus capital MV minus MV divided by M plus M. This MV and this MV goes away. So the answer here is MV divided by M plus M. Great, no? So wonderful problem. I really love this problem. When I did this problem also, I made a mistake. Then I realized that yeah, HCV is not a fool to give these kinds of problems, right? It's a very easy thing. Then I thought, okay, there should be something over here. Then I looked at the response, I got astonished. Hey, how did you get this answer? Then I started working on it. Then I realized, oh my God, I did not read this problem correctly. So the moment we read it, okay, what we think is, okay, it should be with respect to center of the rod, which is wrong, right? So it's not center of the rod, it's the center of mass of the rod, of the system, right? Now, and the rod with respect to center of mass, what is the velocity of the rod before the collision? Before the collision with respect to center of mass? Okay, now we have got it for the particle. Okay, let me write V particle dash. Now, how about the velocity of the rod over here? Now, how do we write it? Any guesses? So, what do we do is, now, see for example, now I am at rest. Now, this is moving. Okay, it's something like I am at rest, then the car is moving towards me. Okay, so now, if the car is moving towards me, I can, now if you ask me, now with respect to the car, what is happening to me? With respect to the car, am I moving? Definitely yes. What direction? With respect to the car is moving towards you, which means with respect to the car, you are moving towards the car, right? You are moving towards the car. Now, what is your velocity in that case? Whatever is the velocity of the car, that is your velocity, right? But in the opposite direction, which means the velocity of this rod is in this direction if I consider the center of mass to be at rest. And in other words, it should be equal to minus VCM. Thus, what is the answer here? V rod dash is equal to minus VCM, which should now be equal to minus MV divided by M plus M. So nice, right? Okay. Every question in HCV is really enjoyable. Okay. I try to solve as much as problems using HCV. It takes a long time, but fortunately, it's a wonderful textbook. No need of any kind of coaching or anything to understand physics. You start working on it, you would love physics to do it. Okay, I love physics and I also expect you people to go through it. I'm not a brand ambassador of HCV or do anything with it. Okay, but still his problems, there's some sort of weightage into it. Okay, to work on it, to understand into depth about these problems. It will take some time for you. Do not look at the answers. There are several books which gives you solutions for it. Do not look at it initially. Try to crack it as much as possible. If you still do not get it more than 3-4 times, then look for the solutions. Thank you friends for watching this video until the end. And I think I took a long time today explaining my interest. So if you really like this video, do share and subscribe to my channel for more updates. You can also write back to me at ratankar@gmail.com as you observe over here. And all the rest of the videos that you need are always been available in this website, which is ratankar.com, right? Okay, thank you once again and see you once again in tomorrow's video. Thank you.